Hi, I'm Toby and welcome to This Is My Architecture from reInvent. I'm joined today by Amulya from GE Digital. Hi Amulya.
Hey Toby, how are you today?
I'm fine. Welcome to reInvent.
Yeah, thank you. It's been great conference so far.
Great. So tell me, who are GE Digital?
GE is the world's largest digital industrial company with business units like aviation, healthcare, power, and digital.
Great, thank you. And what's the solution we're going to talk about today?
So today I'm gonna show you how we made it super simple and easy for our developers to use Amazon services.
Okay, I like that. So do you want to talk me through what we've got on the board here? I see we've got a container runtime. So you've got developers that are deploying applications on containers?
Yes, that is exactly correct. So we have a VPC which is running many EC2 instances, and on those EC2 there is a container runtime environment is running, and developers just push the app to the runtime, and then it is scheduled somewhere on those EC2 machines.
Right. And so presumably one of the challenges you've got with containers is managing state.
Yes.
Yeah.
Yeah, that's a very good point, and that's where the services comes into the picture. So all of the apps in the container runtime environment is stateless, and the state is maintained outside the container runtime environment in the services like Elasticache.
Okay. So I can see we've got an Elasticache VPC over here. So presumably you've got Redis instances that are managing session state for your container-based apps.
Absolutely, that's the use case. So all the multiple instances of your applications share the states with Redis.
Okay. And tell me, why did you choose to deploy a Service Broker API?
The Service Broker API makes it super simple and easy, as I mentioned earlier, to the developers to use a service. So rather than understanding the complexity of VPC, Elasticache subnets, security groups, they just call a Service Broker API endpoint that, hey, looks like the create service, and they get a service instance back.
Okay, so let's say we've got a developer that wants to create an Elasticache instance. Why don't you show me on the board how that works?
So the create is a control plane request. So the Service Broker API works at the control plane level. So the create comes to the Service Broker API, then it internally talks to the Amazon API, specifically in this case Elasticache, and then creates an Elasticache instance based on the payload comes in the create request. So like I need two node cluster, and I need 8 GB of in-memory database.
Right. So presumably one of the reasons you've implemented a broker is so that you can abstract some of that detail and provide standard options to your developers.
Yeah, that's been working great for us because we are providing standard options to the developers. At the same time, we are making sure the security standard for the Elasticache deployment is high. So the security groups, the NACLs, and all those things are as per our standards.
Okay.
And developers don't have to worry about those things.
Okay. So the developers put in an API request to your Service Broker API to request an Elasticache instance according to one of your standard sizes. What happens next?
And they get that. Then they request another API endpoint called service keys to get the endpoint which they can access. And service keys also have things like the URL of the endpoint, the port number to connect to.
Okay. Okay. So I can see we've got a control plane and a data plane. Is this the data plane? Is that how the application container talks to Elasticache?
Yes. So for the data plane, the service broker does not come into the picture. It only comes into the picture for the control plane. For the data plane, the app talks directly to the endpoint which Elasticache exposed.
Okay. Okay. So that's where your that's how your app is going to retrieve something like session state, for example, via the data plane. Great.
Exactly.
Okay. So as you were implementing this, what sort of challenges did you face?
One of the key challenges we faced is because of the container runtime environment, it is not certain where your app going to run. So today it's on EC2A, let's say instance A, and then next hour it's going to be instance B. And at the same time, it is not certain like in which VPC. So it was basically one VPC for all the Elasticache instance. So it's like many to many mapping. And there was no way for us to secure your Elasticache endpoint with just security groups, because security groups primarily works for one-to-one rather than many-to-many.
Okay.
So it was a need for us to give a network level access for all the EC2 machines to all the Elasticache instances in the VPC. So the way we restricted access is, so Redis has a functionality called auth, so auth token. So even though you have a network level access, you will not be able to access the Redis instance unless you provide the auth token. So that was not available in Elasticache. Even though Redis has that feature, but the Elasticache was not exposing that features to the users. So we contacted AWS Elasticache team, and they implemented in just 2 months. They implemented in 4 different regions this auth token feature, and that enabled us to allow us restricted access of app A to app A Elasticache and app B to its own.
Okay, so that gives you your, if you like, your multi-tenant security boundaries, so that tenant A can't see tenant B's data.
Exactly. So the software level auth key token really enabled us to implement this solution.
Great. Okay. Well, thanks, Amulya, for sharing your solution today.
Thank you. It's my pleasure.
Thank you. And thanks, everyone, for watching. This is my architecture.